In the E over M experiment, you will measure the charge to mass ratio of an electron. It's a pretty amazing thing that you can do using the equipment that you're seeing here. On the left, we have Helmholtz coils. They're current carrying wires that are looped, and there's two parallel current carrying wires like that will produce a magnetic field between them. And Helmholtz realized that that magnetic field is constant. So inside the magnetic field, we'll have bulb that has helium inside it, and when we put voltage in that bulb, the filament is going to heat up and shoot off electrons. On the right, we have two power supplies. The top one is a high voltage power supply. It provides voltage to the filament in the bulb so that the filament heats up and the electrons shoot out. The bottom power supply supplies current to the Helmholtz coils, and there are a few precautions you have to take. Make sure that you do not draw more than 2 amps from the, that you don't put more than 2 amps into the Helmholtz coils, because you can break the equipment. Now, we don't trust the lower power supply, so that's why we're using the DMM in ammeter mode to make sure that we're not going to go over 2 amps. So there are only a few knobs that you're supposed to be using here. There's this knob for adjusting the voltage, and that knob for adjusting the current. Do not touch this at all. Do not use that. This can break the equipment. The bulb costs $1,000, so please be careful with it. So I'm going to start turning things on. So here's the current coming on, the DMM. So the current is going to go into the amp range, so I have to put this at 10 amps. So right now I have 1.29 amps in there. It's a bit high. I'm going to turn it down. We don't need that much current. And then I have to make sure that the this knob, the 500 volt adjust knob, is turned all the way to the left before I turn on the power supply. I will increase the voltage here a bit, and you won't see anything in the bulb because it's too bright here. We're going to turn the lights off. But before that, I want to point out this ruler in the back. So you will need to measure the diameter of the circular path that the electrons will take while traveling in the magnetic field. And the ruler back here, you can move up or down depending on how high or how low the circular path of the electrons will be. And that way you can get pretty accurate measurements of the radius of the circular path. So let's turn off the lights. And right now we're seeing a part of a beam. I'm going to turn the current up just a little bit. So now we have a circle. Now if I change the voltage through here, the circle becomes larger or smaller. Same thing with changing the current. The radius of the circle will become larger or smaller. You will need to measure the radius of the circular path for while varying the current. So take a few data points, keeping the voltage constant and changing the current, and then keep the current constant and change the voltage, and then measure the radius of the circular path. When you're done taking all the data, please turn everything off. So turn the knob for the voltage all the way down, and then turn the current off so that we don't leave the equipment on overnight or for too long. Okay, that's it.